AB Calculus, Notecard 7, Intermediate Value Theorem. This is the 7th video lesson in the series of note cards developed by Stacy McMullen, formerly of the Dallas Independent School District. And the Intermediate Value Theorem, which has the acronym IVT, is an existence theorem which says that a continuous function on interval cannot skip values. One problem we have with the intermediate value theorem is it's very much a common sense concept, and one of the big challenges is in properly articulating this very intuitive concept. So if f is a continuous function, you gotta have a continuous function on a closed interval, and k is any y value between f of a and f of b, that is, f of a is less than k, which is k is less than f of b, so a value in between two values in a function, then there is at least one number c in that interval that the x value is between a and b. So f of c equals k. So some key words. Does there exist? Is there a time? Sometimes you will see a word in here called must. Like, must there be a time? That's something to look out for. But the proper articulation that I see works best and most efficiently is this one right here that I'm circling. Let's go ahead. But I'm going to demonstrate a practical use of the intermediate value theorem. There was a reality show called Biggest Loser, and the Biggest Loser theorem is, let's say we have a contestant on the show that weighs in initially at the start of the show at 400 pounds, and by the end of the show, some 17 or so months later, the individual weighs in at 150 pounds. And so you can ask the question, must there have been a time that the contestant weighed exactly 200 pounds? Okay, so I'm drawing this horizontal line here. And common sense would tell you yes, because if we can get to from 400 pounds to 150 pounds by going something like this, so that crosses once, or you could go like this and maybe cross more than once, right? So, but whichever way you slice it, there has to be at least once that it happens. So now the challenge, though, in articulating properly, and in the language of calculus, usually an initial x value you will call a, and the finishing y value you call b. And so you'd have the point here, the finishing point, b, comma, f of b. Okay, and then we will have the initial point here, we would have a, comma, f of a. And the y value where it happens, I'll just pick this one over here, just one of them, will be called k. And then the input value related to that would be c. So the coordinate pair here in question will be c, comma, k. So let's go ahead and look at the problems related to this. 1, use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 1 has a 0 in the interval 0 to 1. And so we can use a for 0, b for 1. And what we're looking for is, the answer to the question is 0 reside somewhere between f of a and f of b. And if the values are different, they could be, these f of a and f of b can be reversed. So that's what we're looking for. So let's go ahead and find f of b. F of b equals f of 1, which equals 1 cubed minus, or excuse me, plus 2 times 1 minus 1. Well, it's going to be 1 minus 1, cancel each other, so we get 2. And then f of a is going to be f of 0, and that's simply going to be the y-intercept of this function, which is going to be negative 1. So f of a is negative 1 is less than 0, and 0 is less than 2. So since, okay, we have to bring out continuity. Since f of x is continuous and 0 is between f of 0 and less than f of 1, according to intermediate value theorem, and I'll just abbreviate IVT, there must be at least one 0. At least 1 0 on the interval 0 to 1. Okay, so now let's go ahead and look at that. Proper articulation is the key. Double asterisks, yes, an actual AP test problem or part of one. A car travels on a straight track during the time interval from time equals 0 to time equals 60. The car's velocity, v, measured in feet per second, is a continuous function. So when you have a table, you can't just take the function like we did in problem 1 and conclude that the function is continuous based on the nature of that. We have to be told that the function is continuous. The table below shows selected values of the function. And here you have on the top row time, which is usually, and especially in this case, an input value, and then v of t, which is our output value. For t is greater than 0 but less than 60, must there be a time when time t when v of t equals negative 5? Justify your answer. And so you're kind of looking where you have v of t, and you're looking here, and where are you going to see negative 5? Well, negative 5 is going to reside here, is going to have to occur somewhere between this negative 10 and the 0 if the function is continuous. So we could say that A would be 35 and B would be 50. So actually the greater, yeah, that would be right. So we would say negative 5 is greater than v of 35, but less than 0, which is v of 50. And what does that mean? Well, it means, therefore, according to IVT, there must be at least once that v of t has to be equal to -5. So that would be a proper articulation. Now, I just happen to choose the t values on either side, immediately on either side of this, where the thing had to occur, but I could have used any of the t values. I could have used v of 0 and v of 60, and still come up with the same conclusion. So I hope that's helpful to you. Again, articulation is a big challenge. Failing this type of articulation that I've done, you can make a long, wordy explanation that this had to occur, the value had to occur between this and this, according to Intermediate Value Theorem. But the most economical demonstration is how I showed it here, which is similar to the notation shown in the beginning of the note card here under part 2, or step 2 here. Good luck, and thanks for viewing.